Well, hey there, folks. Elvis PEMDAS here, talking to you about variables and expressions. Now, I got a question for you. What did Elvis order at the barbecue? He wanted nothing but a hot dog. Basketball.
First thing we're going to talk about is a constant. That would be a value that does not change. So we're just talking about a specific number. So here you can see we have some examples, 32 strawberries, where this 32 highlighted in green is your constant. It's just a number. 1.5 cookies, where 1.5 is your number. It's your constant. And 19/3 miles per hour, where 19/3 is our constant. It is a specific numerical value. A variable is going to be a symbol, usually a letter, that represents the value or values of a quantity that changes. So this time we don't have a specific number of strawberries. We have X amount of strawberries. We don't have a specific amount of cookies. We have W amount of cookies. And here we have H amount of hours. So anytime you have a quantity that changes, we're going to plug in a letter or a symbol, a variable. So here you can see highlighted in red, the X, the W, and the H are our variables. So we leave them as letters in our equation or expression, and then we're going to plug in values for them. Next, we have algebraic expression. So an algebraic expression is a mathematical phrase that includes one or more variables. Now, for our example, we have a word phrase that says, I make $15 per hour. So this is just a sentence. From this sentence, we can make an algebraic expression. First, we need to pick a variable. Now, you can see that here we have $15 per hour. So as the number of hours change, I get paid more money. Now, what we're going to do is say H is going to represent the number of hours. Okay, what does the 15 now represent? Well, 15, that doesn't change. You get paid $15 per hour, or I get paid $15 per hour. That will not change. So that is going to be our constant. So now if we want to write an expression, it's just going to be 15 times H, the number of hours. So from this, I can then evaluate how much money I would make after 4 hours or 5 hours, right? I would just take that number of hours, plug it in for H, and then simplify.
Why was Elvis such a good burglar? He always found the right key. Example time.
Now, example 1 says, write an algebraic expression for the given word phrase. The first says the sum of a number n and 8. So you can see n is going to be our variable, 8 is our constant, and it says the sum. Now we know sum refers to addition. So the sum of a number n and 8 would be n plus 8. And I'm done. Part B, we have 7 less than a number k. Now, you see 7, how they put that in front? That's to trick you, because what this is really saying is we want to take 7 away from k. Now, 7 minus k will not give you the same thing as k minus 7 necessarily. So if we're taking 7 away from k, we want to write it k minus 7. The quotient of a number h and 2. Quotient refers to division. So what we're going to do is we're going to take h and we're going to divide it by 2. So we have our variable divided by our constant. And lastly, we have the product of 5 and a number y. So what we're going to do is we're going to multiply 5 and y together, because product refers to multiplication. So we go 5 times y. You can do that in any order and it would be correct. Anytime you have addition or multiplication exclusively, you can rearrange them in whatever order you want. Okay, and we'll talk about that more when we get to properties of real numbers. So look out for that video.
I'm already a king. Maybe you should try it.
Okay, so this first one says 10 more than a number x. Now, recall when we talked about 7 less than a number k? Well, that had to be in a specific order because it was subtraction. But here, 10 more than a number x is going to be 10 plus x. Anytime you have addition or multiplication exclusively, you can rearrange them in whatever order you want. 10 more than a number x, you can write as 10 plus x or x plus 10. For part B, we have the quotient of 4 and the difference between 2.5 and y. We're going to combine two things here. Quotient refers to division and difference refers to subtraction. So we're going to do the division first. Quotient of 4, so 4 divided by the difference between 2.5 and y. So that would be 4 divided by 2.5 minus y. And that is going to be your expression. For part C, we have 3 more than the product of 5 and a number q. 3 more than, we now know, is 3 plus. The product is going to be multiplication of 5 and q. So we go 5 times q. So it's going to be 3 plus 5 times q, or 3 plus 5q. For part D, we have the difference between 8 and twice a number z. So difference refers to subtraction, and we have 8 and twice a number z. So 8 minus 2 times z is going to be your expression here. Now example 2 says write a word phrase for the given algebraic expression. So this time we are given the expression and we need to write a word phrase for it. So we have n plus 201. That is one way to write it. If you wanted to just write n plus 201, that would be correct. What I'm going to do is get more specific. Since it's addition, we're going to say the sum of a number n, because that's our variable, and 201. For part B, we have 2k minus 7. Again, that is a word phrase that goes with this expression. But I'm going to be more specific. Because it's subtraction, I'm going to say difference. So I'm going to say the difference of twice a number k. Now remember, k is our variable, so it's going to be a number k. So the difference of twice a number k and 7. Part C, we have 3h over 8, or 3h divided by 8. Again, you could say that, or get more specific with it. Because it's division, I'm going to say quotient. We're going to say the quotient of 3 times a number h and 8. Lastly, we have 9z. So, a couple ways to do this. Because you are multiplying, you can use the product. You can say the product of 9 and a number z, or 9 times a number z.
They used to block out my hips on the TV because I was dancing too good. Why don't you try this math problem?
Okay, so again, we're going to take these expressions and we are going to write a word phrase for them. And each of these has multiple answers. Okay, I'm giving you a sample answer, the most specific way I would like you to write it. So for part A, we have the quantity 15 plus x plus 7. Now again, that is a valid word phrase that describes this expression. Or you can get more specific. Because we have addition, you can say the sum of 15 and a number x, because that's our variable, plus 7. For part B, we have 3 minus t, which again describes this expression. That is a valid word phrase. Or you can get more specific. Because it's subtraction, you can say the difference of 3 and a number t. For part C, we have subtraction and division. So we're going to use difference and quotient. So we're going to say the difference of 7 and the quotient of 3 and v. For part D, we have 13 times z plus 1.5. Again, you could say it like that, or get more specific. Because we have multiplication and addition, you can write the sum of 13 times the number z and 1.5. Example 3 says, at a car dealership, a salesperson earns a weekly salary of $150. A salesperson is also paid $200 for every car he or she sells during the week. Using the given information, complete the table below. So here we have expressions for the total money earned by these salespeople. What we're going to do is we're going to not calculate how much money they earned. We're going to examine the expression. Now see here, the number of cars sold is 5. And our expression for the total money earned has their weekly salary and the number of cars times 200, because it's 200 for every car he or she sells. So if I want to figure out how much money you earned after selling 5 cars, I would do 5 times 200 plus 150, because the 150, that is their weekly salary, 200 per every car. So I multiply those together and then add these two. Same thing for 10 cars sold. I would take their weekly salary and add it to 200 times the number of cars they sold. Same thing with 15 and same thing with 20. So if I want to write the expression in this blank spot right here, I would go 150 plus 200, because it's $200 times every car, times the number of cars, which in this case would be 20. Lastly, I have X number of cars, which means X is going to be our variable. So I'm going to plug that in for where I was putting the number of cars sold. So I'm going to put 150 plus 200 times the number of cars sold, which we're going to put a variable instead. It's like a placeholder. So we're going to put X there. So it's going to look something like this. The cool thing now is that we can use this to determine for any number of cars sold, how much money that person would make. All we would do is plug in a number for X, because X changes. That's why it's a variable.
I bet you kiddos didn't know that Elvis got drafted into the Army. He probably thought that information was, private. Oh, you tried.
Okay, so this one says a state park charges an entrance fee of $20 plus $18 for each night of camping. Using the given information, complete the table below. So the total cost is going to be our expression, and the number that changes is going to be the nights that you spend camping there. So you can see here, it's going to be $20 for your entrance fee, and then $18 times the number of nights that you stay. If we wanted to continue this, we would go 20 plus 18 times 1, 20 plus 18 times 2. For 3 nights camping, you would have a $20 entrance fee, plus $18 $18 times every night, so times 3. Same thing for 4, $20 plus 18 times 4. Now, we're going to use a variable instead because the number is changing. So we want to write an expression that we could plug anything in for n, the number of nights. So we're going to do 20 plus 18 times n. Now we have an expression that allows us to plug in any number we want for n to figure out however many nights. Let's say you want to stay 100 nights. You would just plug in 100 for n and you would get the total cost. Now we have our word problem. This says you and some friends are going to a Lakers game. If each ticket costs $65, write an algebraic expression that will give you the total cost of t number of tickets. So let's start with our word phrase. What's our phrase that we're using for our expression? Well, that's going to be each ticket costs $65. Now, if each ticket costs $65, 65, that's going to be our constant. We'll get there. But what's our variable? Well, we say we want an expression that will give you the total cost of t number of tickets. So t is going to be our variable here. T is the number of tickets. The constant we said is $65. So 65 is going to be the cost of each ticket. That's our constant. Now, what's the expression for $65 for each ticket? That would be 65 times t. This expression allows you to plug in however many number of tickets you want, and if you were to multiply that by 65, it would give you the cost of all of those tickets. That's it. You're done.